So this next video, we'll tackle the first prompt. Right, we've got everything prepared. Only change I made from the last video, obviously, is I joined all of the data to each of them, and then I made my symbology a little bit clearer, right? I went in and I changed used family as the main thing to show, and then I changed the colors of water to blue and developed and barren. You do not have to do that if you don't want to. If you do, it's pretty easy to do. And, then just use the same steps from the last video to import the symbology. So the first prompt, backing up real quick, we're primarily focusing today with our local analytics, right? I'll make sure to take good care at the beginning of next class to really rehash the difference between local and zonal and focal. But remember, local, the best way to describe it is, that you have multiple different, I'm going to open get a glimpse into my work right there, a PowerPoint, just to kind of help make a point real quick. Like multiple different rasters that lay right on top of each other, and that each cell maybe doesn't realize what's going on with its neighbors, right? So like, let's say these are blue pixels, and then the blue pixels are going to have some cousins, and those cousins are going to be clear but have like a dark green exterior so we can see them kind of well. And we'll just say like the blue pixels are depicting home sale price, and the green pixels are depicting, like crime density, just for the purposes of the point I'm going to make here. So a local operation, as we define it for ArcGIS, the best it was always described to me is, imagine you take your graph paper and imagine you stick a pencil through one pixel. And that pencil goes all the way through every single piece of your graph paper. So each graph paper that you have, each individual piece, might represent a different quality of the land. One piece of graph paper, one grid might be land cover, another might be aridity, another might be soil quality, another might be elevation. We could go on and on and on here. When you're sticking the pencil through one cell, it actually goes through the same pixel for every other cell, right? So that's really what a local operation does. It allows you to bring together a bunch of different grids depicting different things, but operations are done so that this cell here that I've marked in red, maybe it doesn't know what's happening to the right of it, right? It's not doing an operation that says, hey, if my land cover is forest, neighbor, what's your land cover? What it's actually doing is saying, hey, if my land cover is forest, you, green pixel that's on top of me, what's your elevation? And then purple pixel that's on top of us, what's your average home sale price? Oh, just make sure I got both of them. And then red pixel that's on top of those guys, hey, what's your crime density? Right, so that's a local operation. It's each cell is looking at its identical cell within a bunch of other different areas. So that's what this first operation is going to do here. Each individual cell is going to look at the corresponding cell, the one that's in the exact same geographic area in 2006 and in 2011, and see how it's changed over time. It's not going to look to its left or its right. It's not going to look at the other side of the map. It's simply going to look at another grid in the same place. Right, so to help us understand this, I want everyone just to go to Customize. And remember, also go to Toolbars or Extensions. Make sure Spatial Analyst is turned on. If it's not, none of these are going to work. Once you've ensured that's turned on, go to Customize, Customize Mode, Commands, and type in Pixel Inspector. Drag that up and dock it here. So I'm going to bookmark real quick where I am. I like my extent. We'll call it main extent. Save it. And And I'm going to zoom into just like a random area. I'm going to try to find an area where there's like some difference. Perfect. So I'm coming in like down here. So the first prompt, what it's asking us to do, it says, I want you to create for me a new raster grid that shows me all of the pixels that had a different land use in 2001, 2006, and 2011. So what we're looking for here is something like all those areas, regardless of where they are, that changed from 2001 to 2006 and then changed again from 2006 to 2011. We don't care what they changed to, how they did it. All we're looking for is this idea of like variety. So I could manually do this. It would take me the better part of a century and you might go mad, but you could take your pixel inspector, right? Go to MD 2001, maybe set like a tiny little area here. Let's just do these ones across. All right, there we go. So for 2001, you guys were all 81. And in 2006, you stayed 81. 2011, you stayed 81. All right, you guys were all the same. Very good. All right, let's come down and maybe see you guys. How did you do? All right, I'm going to click on you. You were 21, 41, 21, 22, 41. 2006, you were roughly the same, although there was a 22 in there. 2001, you're roughly the same. So we can see it like that, but that would actually take forever. So what we actually want to do is we want to set up some kind of operation where each of the cells, right, there's roughly however many, 13,535 times 6,975. That's how many different cells there are. We want that many cells, each of them individually, like a piece of graph paper, to look at their respective cell, exactly where they are in the universe, and see, hey, my value's this. What's your value? What's your value? And bring back something for you. And we do that, right? We can't really do that with the tools that we know, right? I mean, we could try to do spatial analyst, map algebra, raster calculator, but that's not going to work, right? Raster calculator is good for doing queries. Like I could say, MD 2011 equals 22, and what I'd be saying is I'd be bringing back all those areas where the land use in 2011 is developed, low intensity. Right? That's what I'm doing. I'm querying stuff, or I'm adding things together. But we can't really use that to answer the question I'm asking. So we have to learn a new tool, which is in local, and it's local cell statistics. So cell statistics is a pretty neat tool. It's almost going to emulate the process that I just showed you, but at an automatic level. So it's almost literally like your pixel inspector is going cell by cell. It's going to look at all the values, for example, that are on this one pixel, and it's going to create some statistic about them, right? So if it found 81, 82, 83, maybe it does the average, the mean, so on and so forth. Now, we're working with nominal data, right? So we always want to keep that in mind. First thing I'm saying is let's look at my three things here. Land cover in 2001, land cover in 2006, and land cover in 2011. Those are the three that I want you to look at. The statistic, it simply says, what do you want me to calculate? And they'll give you some options, right? Mean. So I could take the average of each. That's not really going to be helpful, right? That actually doesn't get us anything. I mean, maybe if like they were all developed, for example, the average of 22, 22, 22 would be 22. But maybe one year it started as a cultivated crop, 82, and then it became developed 21, and then became high developed 24. That'd be weird. I'm not going to calculate it, but that would be like doing the average of 82, 24, and 22. It'd be meaningless because these numbers aren't linear. Right? This might work if maybe we had distances or home sale prices or densities or elevations or concentrations of toxicity in water, right? Something where it makes sense to do an average. And that's kind of the same with maximum or medium. But there's a couple that we can really use and that are very beneficial for nominal values. And those are majority, minority, and variety. So majority is kind of cool. It'll look at all of the values and it'll tell you what happens the most. right? So if something happens 2 or 3 times, that's the value that'll come back. Minority is the opposite, right? It looks at all of them and tells you what happens the least. So if it looked at 3 areas, and maybe to use that example I just gave, if there was one area that began in 2001 as cultivated crops, right? It was an 82. Then it developed in 2006, so it became a 22. And then it stayed developed and it stayed a 22. The minority value would be 82, right? The one that only happens once. So kind of interesting, but not really relevant here. What we're looking at is this final one that's called variety. So this is a really neat tool here. What it's going to do is it's going to look at every single pixel. It's going to look at 2001, 2006, 2011. It's going to drop that pencil through the graph paper, and it's going to return to us 3 values. It's either going to be a 1, if there is no variety, right? If it was the same value all 3 years. It could be a 2. Oh, there were 2 different values across 3 years. Or it will answer our question for us. It may give us the number 3. So if it gives us a variety of 3, it's literally saying there were 3 different values that occurred across the 3 years. So I'll save this one. I'm going to create a output grid on my desktop. You can do that if you choose. Right, it's a relatively larger file, so permit it the time to run the cell statistics. Bing, bada, boom. And just like I said, we're coming back with a 1 and a 2 and a 3. And we can really kind of go in and confirm this if we want. You know, we can zoom on down to this area, right, where this kind of prompt 3 is. And we can look at it, right? This was an area that had several different values over the years, right? It was a different kind of forest one year. You know, it also looks to be forest this year, but if I use my pixel inspector, I could probably see it was a different kind. Right? There's an area that maybe in the first year was a 41, and then it became a 71, and then it became like a 42, right? We can see that changing happen, just like it's telling us, right? You were an area that had 3 different values, versus out here, right, that's always been 41. Oh, always been 41, 41, 41, 41, 41, 41, 41, 41, 41. So that's what I've done. I've taken and I've mapped what's not quite there, right? We've reclassified the world by variety and land cover. Everything that's black did not change at all. Everything that's green maybe changed once, right? It has 2 different land cover values. And everything that's blue changed 3 different times. So that's how you do the first one. Again, it'll be up to you to figure out how you want to show that to me for your homework.